Greetings. Welcome to W4U1 project based approach to instruction. In the last unit, we understood the use of several evidence based instructional components. And in this unit, and actually in the next unit also, we will be discussing the project based approach to instruction. The outcome for this unit is understand features of project-based approach to instruction. Of late, engineering education has become quite challenging. There are a large number of problems that undergraduate engineering education as well as postgraduate engineering education is going through. Let us look at some of the present challenges that engineering education is facing. Expectations from all the stakeholders are changing very rapidly. These days, the pressure has become very severe. Industry, accreditation bodies, and society in general are demanding that engineering graduates must demonstrate at the end of the program not just memorized technical knowledge but higher order competencies. The higher order competencies would include the analysis, evaluate, create, then just not simply execute but implement procedures. And there are also many other expectations other than technical knowledge. These expectations are captured as program outcomes which are specified by the National Board of Accreditation, and they include aspects of professional practice like communication, teamwork, lifelong learning, etc. There are many others. Even the technical competencies stated in the program outcomes specified by NBA include problem formulation, solving complex engineering problems, research literature, etc. These are generally not addressed by many of the courses in the present day engineering programs. Further, metacognitive processing, including self monitoring, self regulated learning, is valued highly in current workplaces, and students do not get opportunities to improve their abilities in this direction. Most of the problems faced in the actual profession are fuzzy, open ended, and complex, which means that there are no clear cut right solutions that are guaranteed to satisfy all the constraints. Current demands from the industry insist that students be trained in solving such realistic problems. These are quite different from end of the chapter exercises. These concerns cannot be addressed by the traditional approaches to engineering education. So increasingly, institutes are turning to other approaches, including project-based instruction, problem-based instruction, experience-based instruction, etc. And they are hoping that through these approaches, they will be able to address the above mentioned challenges. We will discuss project-based approach to instruction in this unit as well as in the next unit. Project-based learning is the term often used in the literature in this context, not project-based approach to instruction. Project-based learning is the more commonly used term. But we use the term project-based approach to instruction to indicate the instructional approach that facilitates project-based learning. So essentially we are saying the instruction that facilitates project-based learning is what we are calling as project-based approach to instruction. So project-based learning paradigm is based on the constructivist philosophy of education. In one of the earlier units, we discussed the constructivist philosophy of education to a certain extent. This philosophy encourages students to actively participate in their learning by creating meaning via experience rather than passively receiving it as in traditional textbook based instruction. So, the active participation is an extremely important one, and the students are expected to construct their knowledge. Project based learning or PJBL, which we will keep calling here onwards, is inspired by two key branches of constructivism theory: cognitive constructivism and social constructivism. Cognitive constructivism, associated with Piaget, focuses on how learners build understanding through individual experiences. Social constructivism, championed by Vygotsky and Dewey, emphasize learning through social interactions and collaboration, highlighting the importance of community and communication in knowledge construction. Both are based on broad ideas of constructivism only, but one emphasizes on understanding through individual experiences and the other through collaboration. As already indicated, we use the term PJBI to indicate the approach to instruction that facilitates PJBL. Project based approach as a term is being used in several broad senses these days. A capstone project in the final year of engineering programs, a common feature in most of the institutes, does not by itself constitute project based approach to instruction. We have been using a capstone project in the final year for many years, and having such a project and then claiming that we have implemented project based approach to instruction is not fair. The capstone project by itself does not constitute project based approach to instruction. PGBA means that project work plays significant role throughout the program and results in PJBL. However, implementation details of PJBA do vary across the institutes. What is the extent to which PGBA is implemented? What are the constraints that the institute is facing? And what are the approaches the institute adopts to face those challenges? All these are different in different institutes. So, they vary across the institutes. Several nearly equivalent definitions of PGBA exist in the literature. Just some of them: a student-centered instructional approach that promotes students to collaboratively solve a real problem by creating an end product. Student-centered is a key concept. Collaboration is another key concept. A real problem is another key concept. An end product, that is also crucial. Another definition: an instructional strategy wherein students collaborate over an extended period to produce a tangible, substantial product. You can see that many of these concepts appear in this definition also. Yet another definition: an approach that emphasizes organizing self-directed learning within an empirical project. It encourages self-directed learning as students take initiative and responsibility for their learning process. Finally, one more definition: an approach that facilitates an extended learning process that utilizes inquiry and challenge to foster skill development and mastery. You can see that though the definitions vary in detail, many of them have certain common themes, like they all emphasize the student centered nature of project based approach, a real problem, an end product, collaboration, like this. The worldwide CDIO, conceive, design, implement, operate. This initiative emphasizes that project based approach to instruction is an instructional method in which students learn a range of skills and subject matter in the process of creating their own projects. This is the approach of CDIO. In contrast to traditional classroom instruction, which often involves passive presentation of material, project based approach to instruction actively engages students in the learning process. So, what are the key features of project based approach? We are listing 7 of them. There are other features, but these are the key features. 1. Learning by doing. 2. Real world problems. 3. Realistic solution. 4. Instructor as a guide and or mentor. 5. Student centered. 6. Interdisciplinary nature of work. 7. Collaboration and group work. Learning by doing. The idea that doing is central to learning was advocated very strongly by the American philosopher, psychologist, and educational reformer John Dewey way back in the early part of the last century. Any approach to instruction does have doing by students as an important component. There is no doubt about it. However, project based approach is different in that it accords a central role to this learning by doing. And the scope of doing is quite substantial. It is just not a small exercise given in the class or a small exercise given as a homework. It goes much beyond that. Practice beyond the final year project work and laboratory work is the focus of project based approach. This approach incorporates project work throughout the program. At least it tries to incorporate into the program as much of the project based approach as is realistically feasible. We will discuss this issue later again. Real world problems. The central position of praxis in the project based approach is linked to doing, being centered on real world problems. This doing, this activity is centered on real world problems. Earlier also, in one of the principles of Merrill, we notice that the student learning improves when they work on real world problems. They work in the context of real world challenges. The real world problems capture students' interest and attention. The problems are generally expected to be complex and open-ended in order to permit a range of possible solutions and also to help students with the problem formulation skills. These two aspects, complex and open-ended, are also extremely important. And problem formulation is one of the competencies that the National Board of Accreditation expects from engineering graduates as specified in their POs. The scope and depth of the problem generally depends on the role it is assigned in the curriculum. Where in the curriculum this activity takes place and how many credits are allocated to this work, and is it part of a course or is it by a course by itself? Is it a mini project or is it a main project? All these things to certain extent determine the scope and depth of the problem. There could be differences in the perceptions of the instructors and students, But essentially, these considerations play a role in defining the scope and depth of the problem. Capstone project, mini project early in the program, mini project in higher semesters, etc. These all do have different scopes and depths of the problems. Department, in collaboration with industry, may select the problems. Problems may be specified by the instructor based on his/her work in the selected areas. In all cases, the problem must be complex and open-ended. It is possible that the instructor has been working over a period of time on a particular type of problems for a longer period, and he or she may suggest such a problem for the student teams. But the important point is that the problem must be complex and open ended. Students may have a choice in selecting one from the available list, or they may be assigned a specific problem. Obviously, choice for students is generally advocated because project based learning is student centered. So, students, if they have the choice of selecting the project, it would lead to a better implementation efficiency as the students get engaged with the problem more easily. There is another issue, can we use simulated problems or the problems must be real ones? Experience seems to indicate that either approach is fine as long as the other features of project based approach to instruction are taken care of. As long as the simulated problem has the features of a realistic problem, it seems to be working as well as a real problem. Couple of examples. Design a low cost solar powered device that can charge mobile phones and similar small electronic devices for users in areas where grid supply is unreliable. See, this sets a context. It's a area where grid supply is unreliable, and it also gives part of the specifications in the sense that it is for charging mobile phones and similar small electronic devices. So these are all the issues which the student teams are supposed to explore and arrive at the specifications for the final product to be built by them. Design and develop a mobile app that enhances the daily experiences of students on the campus by your institute. So, in your campus, the students go through several events during their stay on the campus. There could be cultural activities, professional activities, club activities, there could be other events, and they would like to keep in touch and they would like to network. So, to make their daily experience at the institute a better one, can we design a mobile app? So, design and develop a mobile app for this purpose. Design a sustainable rainwater harvesting system for the campus of our institute. So, this is another problem that is a real world problem and has complex and open ended nature. The next feature is that we must arrive at a realistic solution. The student teams must produce a realistic solution. Project based approach attaches significant importance to the final solution resulting from the project. It is just not learning experience, but it must lead to a final solution which is a product. So, it must be a product of good quality, providing a realistic solution to the original problem. The product can be an artifact, a software package, a professional quality technical report, or anything else as decided upfront by the department and again students if possible. We have the specifications of the end product decided upfront, and the team works towards such a product, keeping in mind all the specifications arrived at and agreed upon upfront. So it must be assessed appropriately based on the specifications and the quality of the final product in meeting those specifications. The choice of the problem and the expected deliverables depend on the planned learning outcomes of the project work. The learning outcomes include technical ones, which are all domain specific, so technical outcomes, as well as outcomes related to professional practice. As we observed earlier, the NBA specified POs include professional outcomes also. So these are related to their practice and they include aspects like teamwork, communication, written as well as verbal, project management, etc. The advantages of explicitly stating the learning outcomes upfront are well known and have been discussed in the earlier modules also when outcome based education framework was discussed. Project based approach to instruction is essentially student centric. Students must have voice and choice. They must be able to express their opinions on the problem choices, the solution choices, the specifications, etc. And they must be able to select one of them after providing a rationale for that to the instructor. Students must be encouraged to actively participate in all the phases of the project and freely express their perceptions. Wherever feasible, students must be allowed to make choices regarding the specific details of the project work. Then what is the role of instructor during this process of project-based learning by the students? It's a corollary to the feature that project-based approach to instruction is substantially student-centric. When it is substantially student-centric, the role of the instructor is more like a guide, mentor or facilitator. It is a shift from sage on the stage to guide on the side. Instructor must relinquish control and facilitate student autonomy. It's an obvious corollary. The learning is substantially student centric, so the instructor must not retain control. Rather, he or she must facilitate student autonomy. Instructor must be comfortable with students assuming responsibility for their own learning. Thus, change in mindset is essential for both instructors and students. While instructor plays mainly the role of guide on the side, it may become necessary for her to provide help to students, bridge the gap between what they currently know and what they need to learn in order to complete a project successfully. It is possible that the project has been selected by the students willingly and they are keen to complete the project. However, there could be gaps between what they currently know and what is required for them to complete the project successfully. So, instructor can step in and provide some form of help. Not a complete solution, but some form of help in the sense of providing necessary material or some kind of help with respect to curated learning materials or with respect to certain tips, etc. This is called scaffolding. We will discuss scaffolding in detail in a later unit. As students gain confidence and competence, the scaffolding is gradually withdrawn, promoting independence. Such scaffolding ensures students can tackle authentic, complex problems by providing timely guidance, tools, and resources. Example of scaffolding: students are working on a project related to the design and development of a mobile app that enhances the daily experience of students on the campus of your institute. What we mentioned earlier as an example of a problem. Students have difficulties with understanding sample UML class diagrams. Data modeling. Instructor can provide a short tutorial on UML class diagrams and further provide a sample diagram if required. So this is an example of mentoring. The next feature is interdisciplinary nature of work. Interdisciplinary projects are preferred in the project-based approach. Equip students with the adaptability and holistic thinking to tackle issues which are beyond rigid disciplinary boundaries. Almost all real-world work scenarios are interdisciplinary in nature, and the project must provide the opportunity for students to work in a similar context. This feature ties in neatly with the next key feature, which is collaboration and group work. Collaboration and group work is another key feature of project-based approach. Student teams engage in a series of interactions over extended time periods, leading them to acquire and demonstrate transferable skills, including communication, the ability to work in teams, play the different roles based on the team requirements, get respect for different cultures and viewpoints, etc. So there are many skills which are not really taught to the students in a kind of formal fashion, but the students acquire them in the nature and the process of participating in such activities. So they become transferable skills, and these are extremely important for the students when they join the professional life. So collaboration and group work leading to the students acquiring and demonstrating transferable skills is another important feature of project-based approach. Depending on the nature of the project, collaboration could be with the industry, social groups outside the institute as well, leading to the development of further professional skills, behaviors and networks. If the project involves people outside the institute, then the project team gains additional experience in interacting with such outside stakeholders, and that promotes their professional skills further. Communication skills include presentation skills, verbal reports, written reports. The communication could be with peers where they are aware of the technical words, jargon and the standard terminology. The communication could be with non-specialists where the students have to translate the technical words or jargon into terms which the non-specialists can understand. So this is another competency which the students need to acquire. Communication with people who are not specialists in the area in which the students are working. Then diverse roles in the team. They could be students could play the role of plan coordinators, solution architects, designer, developer. So these areas keep changing, these roles keep changing, and the students acquire a range of competencies in the course of completing their project work. So that completes our discussion of the key features of project-based approach to instruction. In the next unit, we will conclude the discussion of project-based approach to instruction by looking at the challenges in implementing them and the ways to face those challenges. Thank you, and we'll meet again in the next unit. Thank you.